Chemistry is so hard. I wish Thomson could be here to help me and explain his plum pudding model.
Hello, I'm Thomson and I can help you.
Wait, you're Thomson? I thought you were dead.
Oh, Mr. Thomson! It's such an honor! Thank you for coming to the 21st century. Now, please tell us a little bit about your plum pudding model.
Well...
As the cathode rays carry a charge of negative electricity, are deflected by an electrostatic force as if they were negatively electrified, and are acted on by a magnetic force in just the way in which this force would act on a negatively electrified body moving along the path of these rays, I can see no escape from the conclusion that they are charges of negative electricity carried by particles of matter. We have in the cathode rays matter in a new state, a state in which the subdivision of matter is carried very much farther than in the ordinary gaseous state, a state in which all matter that is, matter derived from different sources such as hydrogen, oxygen, etc., is of one and the same kind. This matter being the substance from which the chemical elements are built up. Translation: by observing the deflection of cathode rays, basically electron beams, I was able to conclude that cathode rays are, in fact, matter, because they have mass. However, the particles of this matter are only about 2,000th of the mass of hydrogen, which was supposed to be the lightest atom. So I called these tiny, negatively charged particles corpuscles. Unfortunately, this awesome name I gave did not last very long. George Johnstone Stoney called them electrons, and everyone went with it. Let's make it simpler then. You see, an atom is not just a blob of matter. It is a blob with littler blobs on it. Those littler blobs are called electrons, which I had the honor of discovering. Get it?
Atoms were thought of as the tiniest division of matter by scientists before Thomson, such as Dalton. However, Thomson discovered electrons, which are subatomic particles that changed chemistry forever.
Yes, indeed. My model must have helped many other scientists develop numerous ideas about atoms.
So, he's a chemist.
But remember that he won the Nobel Prize for Physics.
But wait, what?
Anyways...
But...
Okay, what?
So, Mr. Thomson found out that there are electrons on the atom. But wouldn't the atom be really negatively charged?
Well, since the electrons stick to the atom itself is positively charged, and the electrons, being negatively charged, spread and stick themselves onto the positively charged atom.
Okay, but my chemistry teacher told me that an atom has a nucleus, and inside the nucleus there are protons and neutrons, and the electrons go around the nucleus.
Oh, looks like I've been proved wrong then.
So after Thomson, scientists made many new discoveries. Perhaps the most significant discovery that came quickly after Thomson's model was Rutherford's discovery of the nucleus. Soon after that, Bohr discovered that electrons were arranged in shells.
Well, I suppose I can't be right forever.
Nevertheless, Mr. Thomson definitely has contributed lots to the history of the atom. Without him, people would have had a very different understanding of the structure of atoms. His discovery of electrons and his own plum pudding model opened doors to future discoveries and understandings of atoms and subatomic particles.